Welcome to Spring Your Apps into the Cloud with a PaaS, Platform as a Service. How many people have never heard the term Platform as a Service before? Everyone's heard about it. How many people have actually used one? That's about 10%. That's about normal. All right, so I am Grant Shipley. I'm at @GShipley on Twitter. And the agenda for this long hour-and-a-half session is I'm going to introduce myself and kind of get a feel for what you guys do as well, and then I can tailor the presentation to what you guys are actually interested in. And then I'm actually using a lot of different technologies in this session today. Most of it hopefully will be hands-on demos. I'm going to do live demos throughout the whole thing, and that's either going to be awesome or horrible depending on what the demo gods think. It either goes great or nothing works, so we'll see how it works today. I'm going to talk a little bit about cloud computing, and then we're going to get into the demos. I have 3 or 4 that I worked on for this session. So for those that don't know who I am a senior manager of cloud at Red Hat. I've been at Red Hat about 9 years now, coming up on 9 years in December, so 8.5 years. I was originally hired as a principal software engineer to convert all of Red Hat's legacy Perl code over to Java. And so I did that for the first few years and then sold my soul to the devil and became a manager over software development at Red Hat. So for a long time at Red Hat, I managed redhat.com and all the applications and system administration behind that, including the data center, which gave me a lot of good perspective. Before that, I worked at a company called Novell. Has anyone heard of Novell? The older people in the room, yeah? I don't think they are still around. In some fashion, I think. But I worked there when they acquired the SUSE Linux operating system. I worked on the LDAP directory team and actually wrote the installer for SUSE Enterprise Linux to install the eDirectory iManager stuff that I worked on. And before that, I worked at a small company called Caldera. Has anyone heard of Caldera? SCO? Yeah, I was a senior Java developer there, and we were famous for starting the Linux lawsuits way back in the day. And yeah, I was there when that happened, and Novell acquired SUSE, so I jumped ship to Novell. I got tired of working at losing Linux companies, and then I jumped ship and went to Red Hat. But I've been a Java developer pretty much my entire career. I'm 40 years old this year, so 20 years or so I've been doing Java-based stuff. And primarily I started doing just straight EJBs. Then I went to struts, then I went to Spring, then I came back to Java EE, then I went back to Spring. Never really jumped on the Groovy Grails bandwagon or any other JVM-based language. I've always been pretty much straight Java. But when I became a manager, I wanted to stay technical, and so I actually got pretty big into mobile development when the iPhone first came out. I developed applications for that in my free time. I'm also a huge database guy. Like, that's what I love doing, is working with databases, both traditional relational databases and then NoSQL databases, and we're going to be using both today. And I'm most familiar with Oracle, but I don't put it up there because I'm embarrassed to admit that I know a lot about Oracle. If you're going to Java 1, is anyone going to Java 1? A couple weeks, yeah, I'll be out there giving a talk at Oracle World, actually. So, but I also work on a lot of open source projects. I'm a huge home theater fan, and so I work on a project called Media Portal, which is a home theater-based application for Windows. How many people use that? No one? You guys are killing me. What? All right, but it's a pretty popular system for cataloging your movies and streaming them in your home theater. Do a lot of work on other open source projects as well. So that's me. Also write books. This is a book that is coming out in a couple weeks. You can pre-order it now, or you can just pirate it. I would suggest just pirating it. I think it's like $30, and every time you buy a copy, I make like half a cent or something like that. It's ridiculous. You don't ever write books to make money. All right, so who are you guys? How many people are JEE developers at a Spring conference? Pretty good number. How many people are pure Spring developers? Okay, how many people code in other languages besides Java and Spring? Yell some out to me. JavaScript, C#, Scala, yeah. What else? Clojure. What non-JVM based languages? Got any PHP people here? Ruby, all right. What was that? Mumps, I don't even know what that is. The only Mumps developer in the world is in our session today. Congratulations, we get to learn something. My assumptions for you guys were most of you are JVM developers. You write production applications, and you have some interest in cloud. If you didn't, you wouldn't be in this room to learn about cloud computing. But we all know what assume means. I learned that in middle school growing up. So let's move into tech overview. Some of the things we're going to be talking about today. And I actually love this image because even though I spend my life in technology, it drives me crazy sometimes, right, the evolution. I was actually in San Francisco a couple months ago. I saw this guy walking down the street with his Google Glass on. And I've already given all of my friends permission, if they ever see me using Google Glass, to just punch me right in the face, right? I don't want that. So he's wearing his Google Glass. He had his Fitbit on. Do you guys know what a Fitbit is? It's a wearable for tracking activity. So he had his Fitbit on his right hand. He had his Pebble smartwatch on his left hand, checking the time while he was talking on his cell phone at the same time. I'm like, man, I just want a cabin in the woods and get away from this stuff. But, growing up, I always envisioned, I started using computers in the 3rd grade, and I always thought it'd be awesome if everyone had a computer, right? That was my dream, to not be the geek that knew how to program but tried to hide it from all their friends at school because it wasn't cool back then. Everyone, went through that. And now you can go like 7-Eleven and buy a computer, but, we're turning back into this. My wife, like I said, I'm big into mobile development, and females actually spend more time on smartphones playing games than guys spend playing like Xbox and stuff. And so our society, like, I swear it's an addiction. When we go out to dinner together, we say, okay, no cell phones during dinner, or else we're sitting at the table, checking whatever we are on our cell phone. It drives me crazy. So let's get into tech overview. First thing we're going to be using in the demos is Spring. I don't need to talk about that. I will tell you my story. When I got hired at Red Hat, we ported all the Perl code over to Spring. We were one of the first users of Spring at Red Hat. We were using Spring MVC and Spring Webflow at the time. And most of the applications that me and my team wrote are still in use today at Red Hat. It took us about a year to convert the entire software stack over to Spring. I don't know if you've ever been involved in projects where you port code, but it takes a long time, especially going through the testing cycle, because you forget a lot of things or some edge cases. And then we were supposed to go to production with our new Spring-based stack, and Red Hat had announced the same week we were supposed to go to production that we had acquired a small company called JBoss, who had this framework called Seam. Does anyone remember the Seam framework? So they asked us to not push this stuff to production, but then to port it all over to Seam from Spring, and I basically gave them this and deployed the Spring stuff out. And so, we're still running some of that Spring code out there today. I'm going to be using JBoss in my samples today. But what people don't understand is they hear JBoss and they think it's just a Java EE container. That's not actually true. We have a couple different containers. They're open source, obviously. We have JBoss EAP, which is the enterprise product that's comparable to like WebSphere, WebLogic, those types of things. But you can also absolutely deploy Spring-based applications on them. We have Tomcat 6 and 7 that we ship called JBoss EWS. That's primarily what I use. And then we have JBoss AS7, which is our open source application server, and our new one, which is called Wildfly, which we've modified quite a bit. You should take a look at it. With a new technology called Undertow, which is replacing the Catalina or Tomcat base that is part of JBoss. And we've been able to achieve significant performance improvements by re-architecting the servlet container from the ground up. So if you haven't tried Wildfly, give it a try. My famous demo that I love to do is deploy a Spring-based application on Wildfly. And on the command line, I'll run startup.sh, right, to start the server. I'll show you what I do so you can understand. If you don't understand Linux, so I would do like startup.sh, run that in the background, and then start Firefox with localhost. And by the time Firefox actually loads, JBoss is already up and running and serving the web app, so it starts up super fast. Okay. Delete that. Back to slides. All right, the next thing we're going to be using is MongoDB. How many people actually use MongoDB? Quite a few. What do you think? You like it? Awesome. Yeah. So if you're not familiar with MongoDB and you come from traditional relational databases, MongoDB is a NoSQL database. It's really just a JSON document store, so you store JSON documents in it. A database in like MySQL or Oracle is called a database in MongoDB. Inside of a database, in a relational database, you have tables. Inside of MongoDB, you have collections, okay? Collections of documents. Instead of rows in a traditional database in MongoDB, you have documents, okay? There's no real referential integrity. If you delete a document, it's not necessarily going to do cascading deletes for you, so it's very easy to end up with orphan documents. And it is very forgiving, meaning that if you make a mistake, it'll just happily plug along. I'll show you real quick, actually. Let me break out here, and let me SSH to an application real quick. I'll show you what I mean. So I'm going to go into Mongo here. You can kind of see that, but I'm going to say show DBs. Show DBs, and then I'm going to use Spring Parks. Can you guys see that? No. Let me move it up a little bit here. I'm going to say use Spring Parks. Right? What's the problem? Yeah, I misspelled Spring Parks to Spring Parts, and MongoDB just happily chugs along. And then I would, in my code, be inserting documents into this database that I just created on the fly because I had a typo. I literally spent a week trying to figure this out one time because in one of my REST services, I was storing a new user to a collection called users. And then in the rest of the code, I was storing it in a collection called user. And I couldn't figure out why some of these users weren't showing up, and it was driving me mad. It was because I had a small typo. That's a feature, apparently, because it's schemaless, right? You can just create schema on the fly. You know, if you've done a lot of work with traditional databases in an enterprise environment, depending on how strict your rules are, if you add a new column to a table, they won't let you do that sometimes because you can't have an outage, right? And so I've seen a lot of companies create joiner tables that just joins a new column in. And so MongoDB, you don't have to worry about that. You can just do it on the fly. Neo4j? Neo4j is a graph database, and honestly, I haven't used it, so I don't really know how to answer that. And I am a very informal person, so if at any point in time you want to ask a question, just yell at me, right? I like interactive sessions. I don't like everyone staring at me and you know, not being involved. All right, so the next thing we're going to use is the Layman.com. This is a baseball fanatic, right? And he compiles baseball statistics from the beginning of time. And so you can log in to his website and download pretty much every stat for every player, every team since the 1800s, right? So I downloaded his database, extracted some data out of it, and we're going to use it to predict sports betting. No, just joking. That would be a cool idea, though. The next one we're going to use is called Leaflet. Has anyone used Leaflet before? Okay. Leaflet is a JavaScript library for creating interactive maps that are responsive. Okay, so think Google Maps, but not with Google in your own application. So we're going to be using that. It is open source, and we're going to be using it in conjunction with OpenStreetMap, which is what provides tiles for maps, if you're not familiar with like geospatial type applications. But that's the first app we're gonna look at as a geospatial aware application. All right. Next is called BlazeMeter. We're going to be using that today. BlazeMeter is a performance load testing tool in the cloud. What does that mean? It runs in Amazon EC2, and you can spin up as many servers as you want to run tests against your code to see if it performs. We're going to be using that tool today to run some performance tests. And their tagline is JMeter in the cloud is what they're going with right now. But also, how many people use Selenium? They use the Selenium WebDriver in their test, so you can log in and look at like the screens as they capture them, things like that. You can emulate different browsers. So we're going to be using that. And then lastly, we're going to be using OpenShift. That's the project that I work on at RedHat. And it's the platform as a service, or the PaaS, that is in the session title. But before I get into what OpenShift actually is and what platform as a service is, and specifically how to develop applications for cloud-based platform as a service, it's important for us all to get on the same page on what cloud computing actually is. It's this overloaded term that everyone uses, right? It's gonna, if you're a software developer and your manager has no idea about software development, he probably comes over to your desk or your cube and cloud. We got to move our app to the cloud. Why aren't we in the cloud? We should have been in the cloud yesterday. We're losing revenue because we're not in the cloud. Why aren't we in the cloud, right? But he doesn't really know what it means, probably, right? And my mom knows I work on cloud computing, and and I'm from Tennessee, and so when my mom goes to get her haircut, it's like in this beauty parlor in the shed of someone's house, right? That's typically, where people go where I'm from. But she sits around, and it's very stereotypical. She sits around and talks to the ladies at the beauty salon, and because she knows I work on cloud, even my mom has an iPhone, she is convinced that I work on iCloud, right? Because that's what her thinking of cloud is. So it's important that we all understand what I mean by cloud. But we got to level set first, because we hear all this stuff about cloud computing and how it's going to solve all the problems in the world, right? We should have been using the cloud, 3 years ago. It's going to, feed all the homeless people in the world. It's going to, create world peace. And my favorite is from Red Hat's best friends up in Washington. Who would that be? Microsoft, right? We still hate Microsoft. They had a commercial a couple of years ago, and I haven't seen it in the last 8 months. But it was one of my favorite commercials in the world, because it was a family, and they had just gotten back from vacation, and the mom and the father and the kids were sitting around looking at their vacation photos, and they're just horrible photos, right? And all of a sudden the mom says, "To the cloud," and points her finger up in the sky, and instantaneously these photos are, magically made better, right? And so a lot of companies are spewing this propaganda about how cloud computing is going to solve all these problems, and it's not. It's not going to fix your photos, and it's not going to fix the terrible code that we all write. It's just another tool that we can use, and it's a very beneficial tool. So there's actually 3 main types of cloud computing that you as a software developer need to be familiar with. The first one's infrastructure as a service. Second one's software as a service, and then lastly is platform as a service. When I think of infrastructure as a service, I always think of a crane. Oh, wait a second, wrong crane. This crane, right? Infrastructure as a service actually allows you to do all the building of your stack yourself, okay? A good example is, I said I worked at Red Hat, and I managed the website, www. And the reason I told you that is because we were overhauling. My last project when I was in that role was to redesign the entire website and to throw it on top of a content management system, a new one, which was a Java-based one, actually, so it was a portal that we used. But to deploy that out to production, 2 months before we went live, I had to put the requisition in for hardware. Has anyone done this before at a large company? It's a total pain in the neck, right? So 2 months before, I had to kind of guess at what our hardware requirements were going to be. How many processors, how much CPU. I log into the system, I put in this requisition. I think at the time it was 8 machines, and they're like $20,000 each, so 100 and, whatever, $60,000, whatever the math is on that. And then, of course, because it's $160,000, it has to be approved up by the CFO and goes up the chain. It has to get 4 approvals. And these guys are busy, right? They got other stuff working on. So you end up sending all these emails and say, hey, can you approve this? Can you approve this? They finally approve it. You get a PO number back. You call the vendor back. You say, here's my PO number. They ship you these servers to your data center. Red Hat's data center is actually in Phoenix, Arizona. I would then have to get the delivery date from the vendor, track the package, find out which of my sysadmins are free to fly out to Phoenix, Arizona, send them on a plane. They would get out there the day before, wait around, receive delivery of the servers, take them into the data center, count the number of boxes, make sure there were 8 of them, open up the machines to make sure it had the stuff we ordered in it, right? Put them into the rack. While they were there, they'd also check on power conditioning and cooling in the data center. They would then rack and stack them, what we call, plug the power in network. Actually, they wouldn't even plug in the network in yet. They would plug the power in, hook up a little, have you seen these monitors that you slide around in data centers? Hook that up to it, turn it on, go into the BIOS, make sure the processors and memory match what we ordered. They would then plug in the network, and then finally they would install the operating system, okay? And heaven forbid if we actually needed 10 servers instead of 8, I would have to go through that entire process again. And what happens is most organizations, and I did this myself, if I'm ordering 8 servers, I would try to order 12, just to have 4 sitting over in case we needed it down the road. And then by the time you end up needing those 4 servers, they've been sitting there for 2 years and they're out of date, and you paid 20 grand for them, and now you can pick them up for $3,000, and it's a big waste of money, right? So infrastructure as a service, sorry for the big tangent there, but infrastructure as a service is like setting up virtual machines in the cloud. Who's the most popular infrastructure service provider in the world? AWS, Amazon EC2. We all sit down right now, log into EC2, spin up 2,000 servers each. They'd be ready in 10 minutes. The problem is we'd have no idea how much it's going to cost us at the end of the month because they charge based on throughput, based on disk I/O. Who knows, right? Well, how many people know what their disk I/O is going to be of an application, right? It's just, whatever, right? How much storage you need, what kind of backups. There's all these. Buying stuff in cloud infrastructure services is one of the most complicated billing models I've ever seen in my life. And I look at the bill from Amazon every month because OpenShift Online is in Amazon, and it's very complicated to understand. But they have done a phenomenal job in revolutionizing how you can create servers quickly and be agile as a company to be able to respond to demands. The problem is that as an industry, we have given Amazon more control over the internet than we ever thought we would allow any company or government entity in the world to have. Okay, maybe that's an okay thing, maybe it's a bad thing. But I travel a lot, and this happened about a year ago. My son called me, and he was like, Dad, my computer's not working. I'm like, well, okay. So, and he was like, well, can you fix it? And I'm like, well, what's wrong with it? And he was like, well, I can't stream, or he doesn't say stream, he says, SpongeBob's not working on Netflix. I'm like, okay, restart your computer. I hung up the phone with him, and literally, 5 minutes later, my wife calls me. She's like, you forgot to pay the cable modem bill again, didn't you? Because I don't have it on auto pay. I don't know why. I should just put it on auto pay. I was like, no, why? I paid it. I remember. And she was like, well, the internet's not working. I'm like, what do you mean? She's like, well, Pinterest is not working. I'm like, okay, well, that's not the internet. But then I put two and two together, right? Amazon EC2 was down. And over half the traffic on the internet in the United States, last time, the last article I read was going through Amazon EC2. And so they absolutely, most of the data flows through their data centers today. All right, so that's infrastructure as a service. The next one is software as a service, and this is a love-hate relationship. What's the most popular software as a service provider in the world? Salesforce. I know I'm at a Java conference when I hear Salesforce because that is the enterprise answer to what's the most popular software as a service. Gmail, Google, Facebook, all of these are very popular. People try to argue with me that Facebook is the most popular, but I personally think Gmail is the most popular because everyone has a Facebook account, but everyone has at least 3 Gmail accounts, right? So I think that. But Salesforce.com is absolutely the most popular software as a service for companies. And the reason I say love-hate is because software as a service is the complete opposite of infrastructure as a service. With infrastructure as a service, you're given a virtual machine, but you still have to provide the operating system and everything else to the equation. You still have to have a sysadmin team. You have to, deploy your applications. You have to install your runtimes. You have to apply security RADA updates, set up your firewall. With software as a service, all of that is handled for you. You kind of get what you get and you love what you get, or you don't complain about it because you can't change it, right? You can't really change Gmail. You can't really change Salesforce.com. It works the way it works. And what you have to bring to the table as a company or as a user are your user accounts and your data, but they handle all of the management for you. Okay, that's software as a service. Right in the middle is this thing called platform as a service. And that's what we're going to be using in the talk today. So at the two extremes where we have infrastructure as a service where you just get the machine and you have to do everything, and then at the other end, software as a service, you get everything. Right in the middle is this thing called platform as a service, to where everything is provided for you except your application code, your users, and your data. So you're still responsible for your application and for deploying it out. You can think of platform as a service as a way to create software as a service based applications. And the reason I use this image, which is Darth Vader and Luke Skywalker, is because traditionally in IT, there's two competing groups. There's us, the good guys, Luke Skywalker, software developers, and then there are the bad guys, Darth Vader, which are the sysadmins, right? How many people in here hate their sysadmins? Not hate really, but get frustrated with them. I bet it's 90% of the people in this room. And why are we like that? And that's because we want development environments, and we request them, and we get them about 2 to 4 months later, right? And it took me a long time to figure out why that is, and that's because sysadmins are actually working on things that matter, and they don't really consider development environment high on their priority list, right? Because they're worried about production servers and making sure that they're up and running and that they're applying security RADA updates and things like that. And so, when you request a VM, and I talk with a lot of companies, and you'd be surprised that this is in use at most companies. They have this spreadsheet, and when a developer requests a virtual machine for a development environment, they spin up a virtual machine and then log it in a spreadsheet that you have this virtual machine. Does anybody do this at this company or their company? Yeah. And so then what happens if you get one of these virtual machines is you plug along, you use it, and then down the road the sysadmins are going to run out of space on the physical servers, and they need to clean up these virtual machines. So they send us an email, hey, in a month I'm going to delete this virtual machine, let me know if you're still using it. And we don't respond. And in 2 weeks they send an email, hey, in 2 weeks we're going to delete this virtual machine, send me an email if you need it. We don't respond. A week before, hey, we're going to delete this virtual machine in a week. Let me know if you need it, and we don't respond. And then we get another email, hey, we're going to delete these virtual machines tomorrow. Let me know if you need it. We don't respond. Then they delete the virtual machine, and then that same day we send them an email, what the fuck are you guys doing? Why'd you delete my virtual machine, right? That's very traditional how software development works, right? And that's how it worked when I was in software development. That's how it worked when I managed the sysadmins as well. So I say platform as a service. I use this image because it's where these two competing groups can get along. Like the operations or sysadmin still has full control over the environment, but it's a self-provisioning environment that they don't ever really have to clean up. And a lot of people say platform as a service is something that every software developer needs to learn now because it will be the de facto way that we'll all be developing software in about 2 to 3 years. Okay. So that's what OpenShift is it is a platform as a service. It's fast, it's free, it's open source. So it's free as in, what is that saying? Free as in beer and free as in freedom, right? So it's free across the board. How's that? And we actually, there's 3 different versions of our platform as a service. There's called OpenShift Origin, which is the upstream open source project. There's OpenShift Online, which is Red Hat's cloud that we host for people, and that's free to use as well. You can go to openshift.com, sign up. If you want to sign up now, you can follow along in the demos with me. But to sign up, it's only a username and a password, and we don't even ask for your first name or last name or your dog's name or anything like that. And you can create 3 servers for free, okay? And these servers can run any runtime stack that you want, and they're actually hosted in Amazon, oddly enough, even though I was just complaining about Amazon. They're hosted in Amazon EC2. All right. Done with slides. I hate slides. Okay, you guys bored yet? Nobody bored? How are we looking on time? 1:20. Have I really been talking for that long? Weird. All right, so let's show you our first app, okay? I'm going to show the app and the requirements for the app. I wrote them down here. It has to be responsive. What does responsive mean? Yep, so if you're not familiar with that term, everyone's heard the term, but if you don't actually know what it means that the web app will look good on pretty much any resolution or device. So when you say a responsive web design, it means it's going to look great in a browser, it's going to look good on your mobile phone or tablet as well. So it has to be responsive, and the application is, the client wants a map of the world. And on the map of the world, they want a pin or a annotation, sometimes people call it, on the map for every Major League Baseball stadium in the United States. Okay? They want you to be able to drag the map around and only show baseball stadiums that's viewable on the screen based on longitude and latitude. They want to be able to zoom in on a map down to the street level, like you expect with Google Maps when you drill in. They want to place the pin where the stadium's actually at, the physical address, and they want you to be able to click on it to view the team information, the league that they're in, National League or American League, the salary for the team, list the players of the team, and they don't want you to use Google for this because they hate Google for whatever reason, right? So does that sound like a complicated app? It's not. It's literally like 70 lines of code to do that if you start combining all these technologies. So I'll show you the app here. It's called Spring Parks. This is running live out in production. Pulled up really quickly. And this is a Spring-based application that's using Leaflet, which we talked about in OpenStreetMap. I have the, what are those called? I'm losing my, what? Attributions, that's right. Yeah, so I have their attributions there. They're both open source libraries. And here it is. It's pulling all of this back from MongoDB via a REST service written in Spring. This is the front-end code. We're in Dallas. Is this Dallas here? So we can zoom in. Every time I zoom in, it's taking the coordinates from the edges of the screen to get the longitude and latitude, and then it's calling a REST service, doing a geospatial query based on a 2D index inside of MongoDB to find all the elements within that box, is what it's called. If you're not into geospatial, just ignore what I'm talking about and just know that it's going to find what's on the screen. Right, so we can click on this. This should be the Texas Rangers, ballparks in Arlington. Their payroll is $120 million. Down here is the Houston Astros. Minute Maid Park, their payroll is $32 million. No wonder they suck so bad. If you go up to New York, it's probably $200 million. So we keep zooming in here. There we go, Rangers Ballpark. Well, are they playing today? I don't know. Here's the ballpark, right? All right, so let's try it on the phone. Let me start my I won't be able to go to the home screen, will I? Because, maybe I will. Where's Safari? Here's Safari. It's called Spring Parks Grant. And this is live. You can go to this on your own laptop as well. Load it up here, and it looks very similar, right? So it's responsive. You can click the zoom. And this is all going through platform as a service. Every REST call is going through that. Okay, so let's dive into this application just a little bit, but to build on it, I already have this one running, but to help you guys understand platform as a service, we're going to build it from scratch. The server and everything is going to be publicly available, okay? So let me close my iPhone simulator there, clear this screen. So the first thing I'm going to do is create a new server that's running in the cloud. And I'm going to use a tool chain called RHC, which is what Red Hat provides to interact with the cloud. And if you sign up for your own account, this is how you would do it as well. So this is just the binary RHC, and I'm going to say app create, and we're going to call this, what should we call it? Parks 2, we'll call it, okay? So the name of my application is going to be Parks 2. Then I specify what server I want to use, what language runtime, not what server. So if I just hit enter here, if you don't know, it's going to list them all, right? So you can do Node.js, Perl, PHP, whatever, right? So let's do Tomcat 7, okay? So we'll create that. So what's actually happening right now is it's making a REST call up to the platform as a service, or the PaaS, to say, hey, this guy wants to create a new Tomcat-based server. Okay, it's then going to pick that up, and it's going to provision that container for us. And what that actually entails when I issue this command is it's going to create a Linux user for me on the physical server itself. It's going to install Tomcat 7. It's going to create a private Git repository for me, and it's going to propagate my DNS out worldwide, and it's going to clone my application down locally. Okay, so in that amount of time, we now have a Tomcat server running out in the public cloud, and we can verify that just by hitting it. What do we call it? parks2-grant.rhcloud.com is the URL, and there it is running. It's publicly available, right? So the first step's done. We have our server, okay? Yeah, we for Java-based applications on OpenShift, we support Tomcat 6, Tomcat 7, Wildfly, JBoss AS7, JBoss EAP, so pretty much anything. And if we have time, I'll show you guys today how to run Tomcat 8 on this, or run any application server that you want. Yeah?
All of that with the RedHat command was a wrapper around the calls to AWS, Amazon?
Yeah, so that's what a platform as a service really is, okay? It's an orchestration tier that manages the infrastructure as a service and all the software components for you. Have you ever had this great idea for a new application that you wanted to start in the evenings, right? I'm going to be a millionaire, I'm going to start this application, and you find your hosting provider, you decide on your language that you're going to use, you decide on your database, you sign up for your hosting provider, and by the time you get all this software installed, you've kind of lost interest in the project, right? So you can think of platform as a service as getting rid of all that stuff for you so you can just concentrate on code, right? Yeah?
Let's say you created a Tomcat 7. It says doesn't receive automatic updates.
Did it say that?
Not for this, in general, on OpenShift.
Okay, so the question is, sometimes you'll create a server and it'll say does not receive automatic updates. What does that actually mean? If you were going to try out Vertex, which is a good example. Vertex is a new platform that's similar to Node.js if you think about the async model, but it runs on the JVM. So you can write Node.js type applications in Java or any other language. And when you create this server, is what he's asking about, it says does not receive automatic updates. That means that that cartridge or that runtime was packaged by someone else outside of the core OpenShift team, and we're not going to automatically update it with security errata for you. You would still have to do that yourself. That's what it means. But if, you know, in Tomcat 7's case, if a zero-day exploit comes out, we patch that as part of the platform. Okay. All right, so where were we? We have our application created. The next thing we want to do is add a database to it. And this application is actually using MongoDB. So to add a database, you can either use the command line or you can use the web browser. I'm just going to use the command line while I'm here. I'm going to say, I'm going to change to my parks2 directory, which is my Git repository that was just cloned. And it's a Maven-based project. And while we're on the topic of Maven, you don't have to use Maven. We support Maven, Ant, Gradle. You can just deploy straight WAR files or IR files out, whatever the case may be. All right, so I'm going to add MongoDB. To do that, I say RHC cartridge add MongoDB 2.4. Cartridge. All right, and so what it's doing now is very similar to what it did with Tomcat 7, except this time it's spinning up a Mongo database for me that I can use immediately, right? It takes like 20 seconds. And this is your own private database. It's not a shared schema or anything like that with anyone else. It's its own process that you own as your user account on the platform. And out of the box, we support MongoDB, MySQL, Postgres, you know, whatever the case may be. And here's the login credentials for it, okay? So now we have our application server, servlet container up and running. Tomcat 7 is what we chose. We have MongoDB. Next thing we want to do is get our source code, okay? So the source code for this is actually out on my GitHub, github.com/gshipley, and it's called SpringMLB. So I'm going to copy the Git repo URL here. And then I'm in my directory, I'm in Parks2, and I'm going to add my remote Git repository. If you're not familiar with Git, just ignore this. Think of it as a SVN checkout. Okay. So I'm going to add my upstream repo to the master branch, and then I'm going to paste the URL that my Git repo lives at. Now I've added that remote Git repo. What I want to do now is actually pull the source code down. So I'm going to say git pull -s recursive. Then I'm going to do -x. There's upstream master. Very complicated if you're not familiar with Git. Basically all this does is add a source code repository, pulls everything in, and overwrites what I have locally. Okay, you saw that stupid little template web page I showed you when we deployed the application. It's going to get replaced with this source code. Hit enter on this. It's going to ask me to write my commit message, and it pulled down the source. It's just a couple of files here. So traditionally the way you push code to a platform as a service is via Git. Git actually surpassed Subversion this year as the most popular revision control system. It's at 33% among Java developers, and Subversion's at 31%, and the rest of you guys are probably on Microsoft ClearCase or something like that, who knows. But Subversion and Git's probably the two games in town. So we have our source code now on our local machine. We want to push that up to our OpenShift server. So I'm just going to say git push. And it's sending my source code up. It's stopping MongoDB. It's stopping Tomcat 7, which we call JBoss EWS. And then it's going to start building my code. it notices that we have a Maven pom.xml file, and it is going to start downloading the dependencies that I have in my POM XML to bring in the Spring framework and all that stuff. This is all happening remotely on my server in the cloud. And it takes a few minutes the first time because it's got to download 50,000 jar files. And it's going to compile this WAR file, web archive, and then it'll deploy it out to my server. And then from then on out, any builds that we do, this will be in my local Maven cache on my server, so I won't have to re-download it every time. Yep, you edit your code locally. The build takes place on a different server, right? He asked, what if we need to modify something manually on the production server? I don't want to make fun of you, but that's like a softball. No, you can absolutely do that. You can SSH into the server and modify files directly on the server. Yeah. Yeah, absolutely. Yeah, and we'll actually do some of that a little bit later. So our application's been pushed. Let's see if it actually works. So let me go out to parks2, same URL, and refresh, and the map comes up, but there's something missing. Yeah. Yeah, so the question is, he noticed when I pushed my code that it stopped Tomcat 7 and stopped MongoDB. That kind of sucks, right? Because you don't want downtime. Yeah, absolutely, you can do that, and we'll actually do it a little bit later. We support hot deployment, so you can just push the new WAR file out there, and I'll show you guys that in a bit. Yeah, so I did a checkout. Yeah, so the Maven dependencies, like the actual Spring Framework core jar files, are not on my local machine. With that, okay, you can pull them in. I'm going to import this project into Eclipse in a minute, and Eclipse actually pulls in those to be able to resolve code completions, things like that. All right, so what's missing on this map? Data. So let's add our data real quick. So I'm going to SSH to my server, like you were just asking. Maybe I want to do something on the production server. I'm doing it this way to show that you can. You would never import your data this way. I'll show you how to actually, you should do it a little bit later. So I'm going to say, I'm going to SSH into my server. I'm going to say RHC app SSH. This is just a shortcut. You can see that's my user ID and my host. I could have just SSH'd using SSH, but I just used the wrapper command. So I'm on my physical server now, right? That's running. I can look at uptime. This server's been up 41 days. So I want to run an import command. So I'm going to cheat a little bit, and I'm going to view the import command so I don't have to type it. It's called post deploy. All right, this is it. So I'm going to run this Mongo import command, and I'll walk you through what it actually does. So I'm saying Mongo import a JSON array is what it's going to be coming in as. -D is the database name, and if you're not familiar with Linux, you're probably wondering what in the heck that $ OpenShift app name is. That's what's called a system environment variable. Most people are familiar with this in Java land because you have this class path, right, that you add things to that gets set as a system environment variable. Well, with OpenShift, because it is a platform as a service that can automatically scale, which we'll get into in a bit, your IP address may change, right? And so in order to get around that, we feel the best practice is to reference your host, like your database host, via an environment variable in your code, so you're not actually putting IP addresses, things like that in. So the OpenShift app name is just the name of my application. I'm passing in -C for the collections. I'm going to create a collection called teams that I'm going to import this data into. And then I specify the JSON document I'm going to import and the host, username, password, all that. So I'm going to run that. It imported 30 objects. The next thing I want to do is create a spatial index, a 2D index. So I'm not going to really explain this because you either know what it is or you don't. And if you don't, you probably have no use to know what it is because you don't deal with geospatial type queries. But essentially, it's creating an index. It's an index that can handle spatial queries to do like closest distance to something, things like that. I'm going to add the index. So now we have our data loaded, and we're going to reload, and now we have our maps that's returned, or our parks that's returned from the JSON document. Okay. Say it one more time.
What if you create another Mongo instance?
So you can only have one Mongo instance per application. Okay, so you couldn't really have another one. You could have multiple Mongo instances for different applications. You could have a Mongo, a MySQL, and Postgres, for example, in the same application, but generally only one type of the same database per application running in the platform itself. You'd obviously connect to 1,000 MongoDBs if you wanted to. Does the platform support replica sets? And probably sharding is probably going to be the next question if you're not familiar with MongoDB. The answer to that is no inside of the platform. If you wanted to do MongoDB replica sets, you would use one of our add-on cartridges that's provided by like Mongo Lab or Mongo HQ that does provide that, and then you would connect to it. But it would be running on a different server, not in the same application. Yes? How did it understand where to push the code? Okay, that's a good question. If I exit out of my server here, I'm in my source code directory for this application. If I look at the .git/config, it adds a remote repository for me when it clones the code. That is my username and my host, where the Git repo lives. This is all running, what I'm showing today is all running on Red Hat Enterprise Linux, running on Amazon EC2. Yeah.
How does the web application know what MongoDB connected?
Yeah, when you embed MongoDB into an application, we set those environment variables. Oh, how did my code know? Is that what you're asking? Oh, okay, I'll show that in just a few minutes. I'll show you the actual code. Question back here? Yeah, the question is, can you talk to different databases in like dev, QA? We had stage environment at Red Hat and production. Yeah, absolutely. You can set up. Yeah, without application changes. That's a lot of information to cover, though. I mean, if you're really interested, send me an email and I'll send you the chapter from that book that I just finished that explains it all. Yeah. Okay, where was I? All right, we imported the data. Okay, sweet. So it's working. But that was kind of a pain in the neck. That's still too much work for me to do. And so what you can actually do, if I go up a directory, you can chain commands together. So I could have said rhc app create parks3 tomcat 7 mongodb 2.4, chain them all together from code. Oops. Pass in my Git repo, make it scalable, and it'll do everything I just did in one command, right? Set up the entire app, download the source code, build it, deploy it. It honestly, I timed it, right before this session, and it took about a minute and 53 seconds to do the entire stack. I am running on the free tier. All of this is running on the free tier today. What? The S just, I'm setting this up for later in the session, but that specifies that we want that app to be automatically scaled, okay? And we'll get to that in a minute. So that's working. Let's go back to the slides. Yeah. Yeah, you can, the question is, does it always deploy from master, or you can specify branch? You can do everything from disabling auto deployments to specifying branches, submodules, anything you can do. Yeah, we support all of that. All right, so this comes back to your question earlier. What happens when you need to log into the server and make a quick change? How many times have we pushed something out to production and realized, oh crap, I made a mistake, or it's a problem that has to be fixed immediately, right? So I want to show you how we handle that with our deployments and rollbacks. So what we're going to do is I am going to go to this window here, go into code, Spring, and were we using Parks 2 or Spring Parks, I think? Okay, so let's go into, let me just remove this because I don't know which one we're using, and I'll just clone it again. Okay, so now I have my Spring Parks application. Spring Parks, let's go into source main web app and look at the index.html file. And there's the title. MLB stadiums, we're going to change this at Spring 1 3GX. Okay, I'll save that. And then I'm going to commit this change. And then the next thing I'm going to do is configure my application to keep deployments. And so I'm going to say RHC app configure -- keep deployments. Did I type that right? 10. And then I'm going to say git push. And this is going to push that new change up to my server. We can see it's stopping again. I should have enabled hot deploy. Remind me to do that in a minute. Hopefully it will use the Maven cache and not re-download everything. Should take about 30 seconds here. And you can see by default we do skip test. You can enable tests if you want. It's compiling the new files. It's deploying. Starting back up. Spring Parks. Refreshing, it's compiling. There we go, MLB stadiums, let's bring 1 3GX. Let's do this one more time. I did this backwards. I should have done it right the first time. I'm going to do something real quick. Ignore this. I'm just going to make it faster. Okay. I enabled hot deploy so it wouldn't actually stop those services. Oh, maybe I did. Maybe I typed something wrong. I don't know, because it says it's still stopping it. All right, so I made a change, and I changed it to Spring 1 3GX, and then I did another change to change it to Spring 1 2GX. So it's building this up. It's going to deploy it here. All right. It's activating the deployment. Okay, so our application's been deployed. I want to refresh this page. It's loading for the first time. We're all used to this, that it takes a while. So now we have Spring 1.2 GX. Well, Pivotal decided to change the name of their conference to Spring 1.3 GX for next year. We just pushed this out to production. We need to roll it back very quickly. So I've seen a lot of companies do a lot of different things. At Red Hat, anytime we deploy an application out to production, we actually take the WAR file and we package it up as RPMs. If you're not familiar with Linux, it's a packaging standard for Red Hat-based systems, and then we deploy those out. To roll back, we would bring half the cluster down, update the RPM, or roll back the RPM to the previous version, put that back into rotation, take the other half of the cluster down, and do that. So with OpenShift, we realize this happens a lot, and so we actually track all of your deployments. So I can say deployment dash list. Let me clear this and run it again. So you can see we have a couple of deployments. You can see I first created this application at 9:48 a.m. this morning, right? And then we have our deployment at 1:46 and a hash, and a deployment at 1:47 with a hash. And the 1:47 deployment is the 2GX. So we want to roll back to a previous deployment. So to do that, I can just say RHC deployment activate and pass in a hash. And this is a single server, but if it was in a clustered environment, it would actually do that graceful rolling deployment across the entire cluster and roll them back, and then add them back into rotation into the proxy. All right, so we should be rolled back. I don't know, let's see. That seemed to happen pretty quickly. So if it worked, we should see 3GX now. You never know with live demos. So come on, you can do it. Pardon? Okay, I'll explain that in just a second. So we can see that it worked. We rolled back to 3GX. It had to compile again for the first time. You guys are all familiar with this in Java land. So when I did the deployment list, if I had a pointer, I would show you. But these are, anytime I do a git push and it builds the WAR file and deploys it out, it tracks it. And then I can roll back to any one. You can see that at 1:49, I have a deployment hash that matches the one at 1:46 and a message that I rolled back to the 1:46 deployment. And then you can roll forward or whatever you want to do. Is that what you say? Roll forward? Roll back? Roll forward? That's a good question. The question is that against the git hash? If you're not familiar with Git, it creates a hash of every commit, and I don't know the answer to that. Yeah. You know what? Thinking about it, it would have to be the git hash. Yeah, because we're not creating one, so yeah. All right, so that is rollbacks. Now let's move into something a little more exciting than rollbacks, and that's called scaling. Okay. There are two types of scaling. There's called vertical scaling and horizontal scaling. Vertical scaling is traditional IT, where you have a Java application, and as your users increase, what do? You add more memory to the problem, right? So we end up with these huge servers with like 64 gigs or 128 gigs of RAM, 8 CPUs with 8 cores each, right? And so that's vertical scaling. you scale up. You add more hardware to the same physical box to solve the problem. Well, with cloud computing, and particularly platform as a service, we've now shifted to doing what's called horizontal scaling. And that is, so I'm from the South, right? I said Tennessee, and I don't know if Texas has the same problems, but I chose this image because if I would be outside eating a bag of Doritos, which I like to do, obviously, I eat a lot of Doritos, and I dropped a chip on the ground, pretty quickly, an army of ants are going to come and eat that Dorito chip. But a single ant doesn't come and pick up this Dorito chip and carry it back home, right? What happens is a complete army comes, they decimate the chip, break it into a million little pieces, and each ant carries a small portion of the chip back to their home, right? And so that's how you can think of horizontal scaling. It's a lot of small servers tackling the problem and serving requests via a load balancer, okay? And so it's very easy to scale out horizontally. It's traditionally a lot harder to add memory on the fly to an application, right? Do they even have hot swappable memory? Open up a box and I don't know. But that's horizontal scaling, right? And so that's kind of how we're moving as an industry. And there's also two types of way to achieve this horizontal scaling. The first one is manual scaling. And manual scaling I'm not a friend of because I managed the sysadmins for so long. But it's literally, and I chose this image because these monitors are old CRT monitors, and that's how I envision manual scaling, is the way we did things years ago. We shouldn't be doing manual scaling anymore. When I say manual scaling, I mean sitting at a command line saying app scale up, right? Add additional gears. That's manual scaling. Like, we shouldn't have to do that. And so this is a guy, a sysadmin, probably sitting at his desk, falling asleep, just waiting to have to scale up his servers, right? But what we actually want to achieve is to be out all night partying at a rave as sysadmins and not have to worry about our applications, knowing that if we get featured on the App Store, if it's a mobile backend, or if we get on Reddit or Hacker News, or and our application is suddenly very popular, it'll just take care of it itself, right? And the sysadmin doesn't really have to be on call anymore. It's just going to happen itself. So that's automatic scaling. And with OpenShift, we absolutely support manual scaling, but the biggest benefit of our platform as a service versus the other ones is that we automatically scale based on criteria that you set. Okay, out of the box, we automatically scale based on the number of concurrent HTTP requests that your application receives. If it ever has more than 16, we'll add another server to the load balancer, and we'll show that right now. Okay. So I created that scalable application in this window called Parks 3. Okay. So I'm going to make sure that it's up and running. parks3-grant.rhcloud.com. Okay, it is running. We don't have the data yet, so I'm going to say RHC app SSH parks 3. I'm just going to create the data real quick. Hopefully I still have that window open. I do. Oops. Now I'm going to create that 2D index again. Boom. Oops. Okay, so now our application's up and running. This one actually has a load balancer already. When I pass that -s flag, that's really what happened, is we created a HA proxy load balancer to front your application. So let's do a performance test. I'm going to go out to blazemeter.com, which I talked about in the tech overview section, and we're going to create a load test real quick. Come on, Blazemeter, you can do it. So I'm going to add a test here, And we're going to call this one Spring Parks 3, 4, 5 GX, 7 GX. We're going to do get and post request. We're going to say the map is going to be this URL. We're going to test that. Then we're going to test the REST-based service. What is that? That's going to be, what did I call it? I called it API v1 parks. Yep, that's the JSON. Paste that in here. And let's do 3,000 concurrent users. We're going to do a request every 3 seconds per user. Stress, and let's save this. And then let's start the test. Launch servers. So this is going to spin up, it looks like 4 Amazon servers to run my load test for me. So 3,000 users is actually quite a bit, right? Doing a page view. I would say that probably translates into, so if we're doing it every 3 seconds, 3,000 users, a typical user at a real website is going to be on a page for what? 10 seconds, 12 seconds at least. So we're really simulating probably about, I'd say 30,000 users hitting an application with the amount of traffic we're going to be sending it. So this is spinning up. We're going to let that run, okay? But while that's running, I'm going to open up another page here, going to our Parks 3 application, and I'm going to look at the HA proxy status page to where we can see our servers. This will grow over time. Right now we have 1 server serving up our request. So let's let this run, okay? And let's go back to the slides. Yeah?
How does it translate to TPS, transactions per second?
What happened? Whoa, that's weird. The projector just flipped out on me. Let me fix it. How does it translate to transactions per second? I have no idea, quite honestly. It just, depends. Yeah? Yeah, absolutely. Yeah, we support that as well. Yeah. What happened to my machine? Let's close this. Let's go here. The next slide's awesome, I promise. PowerPoint crash? Is that what happened? PowerPoint crash. Force quit. That always helps. Uh-oh. That's not good. All right. Here's my next slide. There we go. All right. So we did deployments and rollbacks. We did automatic scaling. The next thing we need to be concerned about with Java-based applications is memory utilization, right? And so if you clone that Git repository that I wrote, there's a REST endpoint at /hog based off of Boss Hog, if you're familiar with Dukes of Hazzard, that's just going to eat all the memory on the machine, okay? And it's eventually going to throw out a memory exception. It's going to consume it all. Well, with OpenShift, we have this system called Watchman that runs on all the servers, and it's a self-healing system. So if your application actually runs out of memory or any other common mistakes, it's a catastrophic failure for your server, we proactively restart the server. It takes about 20 seconds for it to come back. So even if you OOM, it's going to be back within 20 seconds or so. And Watchman. That's what it's called. Pardon? If it keeps on, the question is, what happens if it keeps on dying? We'll keep on restarting it. There's no limit. We're just going to keep restarting it because it's a quick operation for us. It's just starting up JBoss again. All right, so this is all great. We have everything running in the cloud, but how do I actually connect to things running in the cloud? What if I want to debug my application code? So you have to be able to punch a hole through the firewall some way or another, right? So I'll show you how to do that while our load test is running. I'm going to start up Eclipse. Eclipse has already started, actually. And I'm going to import this project. So there are Eclipse plugins for OpenShift, and so hopefully you can see this. I'm just going to say create a new OpenShift application. I'm going to select my account, and I'm going to log in here. And I'm going to say use an existing application, and I'm going to choose Spring Parks. Click OK. Click Next. I'm going to create a new project. Yeah, click on Finish. And so this is actually connecting to my remote OpenShift server, cloning that source code, and creating an Eclipse-based project out of it. And I'm doing this because I want to show you how to debug your applications, look at your log files, be able to connect to your database. Because right now we have this Mongo database, but we can't connect to it from our local machine. The only thing that can connect to that Mongo database is the server that the application's hosted on, which kind of sucks. That's why I SSH'd in to import the data, because I couldn't connect to it locally. Well, with port forwarding, we can do that. And so here's my Spring MLB application, and man, we're really running out of time. I talked way too long. Here is the REST service. That's all it is, right? But I'm not going to walk through the code. We're running out of time. Download the code, and you can walk through it. But what I want to show you is I can go to my servers tab here, and I see we have this Spring Parks. I can go to OpenShift. I can look at my log files right inside of Eclipse. I can restart the application. I can add additional cartridges. Like if I click on this, I can select to install multiple MySQLs, Postgres, whatever else. But I can also do this thing called port forwarding, which will forward both the Java runtime and the MongoDB database via SSH, so I can connect to them from my local machine. This is how you would set up debugging. You would enable JPDA, then port forwarding, and then you would just click the debug button in Eclipse like you normally do. Okay.
OpenShift is an Eclipse plugin?
It is, yeah. Yep. You just download the plugin there. All right. So let's see what else I want to cover real quick. What time is it? What time does this end? All right, we're going to go quick now. All right, we're almost out of time. I want to talk about Appcelerator real quick. I'm huge into mobile development. I'm a huge Appcelerator fan. It's a way to develop native mobile applications. How many people have used Appcelerator? Okay, you write basically JavaScript code that gets translated into Objective-C or Java, and it actually runs natively on the device. It's not running inside a web view or anything like that. That's Appcelerator. Second piece is called Twilio. Twilio is a cloud-based communications tool to allow you to do voice-based systems. Like I wrote an application, you called a number, like a telephone number. Everyone's done this, right? They pick up, and it's an automated system. It's a tool to allow you to develop those types of applications, very simple to use. It also allows you to do SMS type messages. Okay, so let me exit out of this. Everyone pull out your phones. Everyone pull out your phones. Pull them out, pull them out. And send a text message to this number. Here's the iPhone application. Keep it clean or not. I don't care. Say whatever you want. Right? And this is a Spring-based application that I wrote for this session. And this is all running on OpenShift. Dallas, Texas says howdy. Let's wait for a few more to come in here. Fubar, Garden City, New York. Salt Lake City, that's you right here, South Salt Lake City. Hello, great session. Omaha. Hello, Dallas. North Carolina, who has a North Carolina? You're from North Carolina? I'm from Raleigh as well. Where do you live at? Okay, I live down southeast Wake County. All right, Spring 12 GX. So there it is, Phoenix, Arizona. Who's from Phoenix? I just moved from Phoenix. I lived up in Peoria. Yeah, I moved. I guess it's been about 2 months. I moved in late June is when I moved. But I lived in Vistancia up in Peoria. So here's the application. It is just a simple mobile application. And I'll show you that code real quick so you can see that it's very easy to do. All I'm doing is connecting to this. And this code is also on my GitHub. But this is just a Spring-based REST service that receives SMS messages, strips out the from, state, city, and the actual text message itself, stores it into my Mongo database, and then I F-bomb for the win. Nice. And then I just present it in the phone, okay? So that was real quick. I had planned to go into a ton of detail on that and show you how to do it, but you guys should have shut me up. I talked way too much earlier. I apologize for that. What we got here? Nothing? An empty slide. I guess that's the end of the presentation. No. All right, so let's go back. Where were we? We were at scaling up, right? So let's spend the rest of the time checking on our scale up, because I promised all this fancy automatic scaling. Let's see if it actually worked. Okay, so you can ignore anything past this because that's just the way they present their data. It's all over the place. Right now we are at 1,600 concurrent users. Let's see how many servers we got. Parks 3. Status. So far, we've only scaled up one additional server. So we have our local gear, which is a Tomcat 7 server, and then that gear above it is a Tomcat 7 server as well. So what happened is when it reached that threshold of concurrent connections, we spun up another container, rsynced the code over from the original container, deployed the code, and then added it to HA proxy, and we began doing session affinity across those, okay? And we'll continue to examine your app. If traffic goes down to where we know this will spin up to like 15 servers in about 5 or 10 more minutes. If we no longer need those servers, we actually automatically spin them back down, terminate the sessions, and then remove it from HA proxy. Yes. Yep. They're all connecting to the same database. So let's refresh this. See, I was hoping it would be up to like 5 or 6 servers, and this is running on the free OpenShift.com tier. These servers are 512 megs of RAM. So you're probably looking at me silly, running Java-based applications in 512 megs of RAM. But we've actually optimized our Tomcat distribution and our JBoss distribution to run pretty good in 512 megs of RAM. So you can do all of this yourself, right? It doesn't. HA proxy is responsible for load balancing. Let me refresh. Hopefully we have another server up by now. Nope, not yet. Dang it. I was hoping to get this thing up a lot. Okay, so right now, we have this thing called local gear. That is HA proxy plus Tomcat 7. And then we have this gear with a hash or whatever. That is just Tomcat 7, okay? So local gear is actually HA proxy and Tomcat 7 combined. When we get up to 2 more additional Tomcat 7 servers, what we do is we take Tomcat 7 off of that local gear that's shared with HA proxy to only have a single HA proxy machine because so much traffic's coming in. Then once we get up to 4 Tomcat 7 servers, we actually scale out HA proxy as well. So we'll have multiple load balancers handling traffic, is how it works. Oh, this demo turned out to be sucky because we only scaled up to 1. How many users we got right now? We're up to 2,200 users. So even on 512 megs of RAM, that stupid little map application, there we go. We added another server, is handling. In my best estimate, giving normal web view statistics, I would say at 2,000 users with our load test, we're probably at really 20,000 real users, which is a dream come true to have 20,000 users looking at your web application, right? And we're handling that with, right now, 3 512 servers horizontally scaled. All right, we're out of time, so I got a couple of minutes for questions. Yep, first right here.
Didn't we start with scaling instances of like the app servers before we started scaling the entire operating system?
We're not scaling the operating system. These are containers. This is very different than how we traditionally do IT. We're not spinning up a virtual machine. We're just doing a container. Under the covers, we're using, if you're not a Linux guy, you probably are not familiar with these technologies, but SE Linux, which is Security Enhanced Linux that Red Hat co-developed with the National Security Agency, so you can blame us for all these cell phones. Linux control groups, which is how we do process segmentation to specify how much CPU memory you have. And then Linux PAM namespaces for polyinstantiated directory, so we can namespace like /temp directory. So when I spin up another gear, I'm just putting a new container, new policies on the machine to create this secure environment. Yep, first right here. Go ahead, yeah. Yeah, you mean for your domain? Yeah, so everything I showed you was like this stupid parks3-grant.rhcloud. The way you add your own domain name and security certificate, I'm already logged in here. If I go to my applications and go to settings, let's see, domains, authorizations, SSH keys, maybe it's under applications. Hang on, it's been a while since I've looked at this. Parks 2. Oh yeah, this is how you do it. So here you can specify your own SSL certificate, and you can also add a CNAME for your own domain name as well. You can also, I showed you automatic scaling. We're up to 5 now. Awesome, we're up to 5 gears. If I click on an application and click on this, I can actually set min and max. So if I always want 10 servers running, if I just know I have that much amount of traffic, I can always do that. If I know I have a big product release tomorrow, I can go ahead and add it to 50. Okay, any other questions? Yeah. What about the DB level? Okay, she asked if I scaled the web application server Tomcat, but what about the database? We do not automatically scale the database. Okay, it's a single database instance. By default, you would have to use something. For Mongo, you would use Mongo HQ or Mongo Lab, which you add to your application. You just go to marketplace.openshift.com. Instead of adding it the way I did, you would come in here and go to like Mongo Lab. It's free to use. You would just click on Add, and it will add a replicated Mongo database to your application. Yep. Yeah, back here. Spring Cloud Connector integration. I don't even know what that is, to be honest. Oh, you're talking about Cloud Foundry? Is that what you mean when you say Spring Cloud? Or what's Spring Cloud? I'm not familiar with it.
I was just at the talk this morning, some newfangled thing that they're doing to replace stuff.
Oh, okay. Yeah, so no. That's probably hooking up to Cloud Foundry, which is Pivotal's attempt at a platform as a service. Okay. Okay, yeah, I'm just not familiar enough with it to intelligently answer your question. Sorry. Yeah. Yes. Yeah, so MongoDB in this case is actually running on its own server by itself. So a whole year just for MongoDB. And so it's able to keep up pretty well with the amount of traffic. But again, the way we did it today, it's not replicated, right? So it is a single point of failure the way that I spun it up. You'd probably want to use the replicated database for a production application. If it's for development, then who cares, right? Let's see what we got. Oh, well, now we're getting somewhere just as the talk is ending. We got 4 servers now. Pardon?
How does the code know?
Oh, how's the code? Yeah, I promised I would show him how the code knows, and I forgot. All right, so here's the code for this real quick. It is a single database, right? So let me show, where am I? Oh, I'm here's the code that creates the Mongo database connection. And even in my Java code, I'm using the environment variables because this is going to get executed again on the remote server. And we set those environment variables the very first thing when we spin up a new container. So no matter how many servers I have, it's going to each server is going to have the correct information. Now, if you're deploying, if you're testing or developing locally and then pushing to the cloud for production, you would just want a little ternary if statement here that if that system environment variable is not defined to go to localhost or wherever, right? Or you could have it set for dev or QA or whatever. Yeah.
So when you scale, you spawn a new gear, right?
Mm-hmm.
But this reads from the system, so those environment variables, when you spawn a gear, does it point back to the original MongoDB?
It does. So each gear has its own unique set of environment variables, and they all are going to point to the MongoDB database that I first created. Okay. All right. Yeah. I do, yeah. So if you want to run this internally in your own data center and you hate the public cloud and you never want to use it, go to openshift.github.io. And here you can download all of the code. We also provide virtual machine images if you just want to spin up. Like I run it myself because I don't want to deal with installing Node.js when I want to try it out. So I run my own private OpenShift just on my local laptop using VMware Parallels. I just download the VM image. They're right on this GitHub page. You can download it. You can deploy it out on CentOS, Fedora, or RedHat Enterprise Linux. Yeah, it's like a 2 gig VM image, or no, it's 800 megs actually, the origin VM image. You can just spin it up and run it. Yep. Yeah. Yeah, okay, so there is a script, and I wrote a blog post on this, so search for OpenShift scaling Grant Shipley, and I explain where that script is and how it works, and then I also show how to modify it to scale based on the amount of memory utilization that your app is consuming, okay? But that's how, it's a Ruby file, actually, that, if you're familiar with Linux, there's the proc file system. You can peek into the proc file system to look at your memory and things like that, or we look at the JVM usage statistics. Okay, cool. Well, thanks everybody for coming. I really appreciate it.